Solving two-step inequalities and multi-step inequalities, the first thing you're always going to want to do is undo your addition or subtraction first, just like two-step equations. So we're going to add 4 to both sides first. So you get 5x is greater than or equal to 15, and then divide by 5. So you're going to get x is greater than or equal to 3. When you go to graph that, it is a closed circle on 3 and everything shaded to the right. So in number 2, we're going to add 7 to both sides. These are just like equations. So add 7, you're going to get 12 is less than 6y. And then divide by 6, so you get y is greater than 2. And then when you shade, it is going to be an open circle at 2, and then everything to the right, because it is backwards right now. So you'd read it as 2 is less than y, therefore y is greater than 2. Number 3, you're going to have to subtract 4 from both sides. So you drop down your negative 3r is greater than or equal to 15, and then divide by negative 3. And the key piece for this lesson and this chapter is if you divide by a negative, you flip your inequality symbol. So it's negative 5. So r has to be less than or equal to negative 5. So that is your negative 5, closed circle, shade to the left. For the rest of these, I'm just going to put an answer. Number 5, make sure you distribute first. Number 7, make sure you combine like terms. You'll notice that now all of the rest of the problems are filled out. In number 4, we just simply subtracted 2.3 from both sides, then divided by 0.5 to get h is less than negative 21. Open circle, shade to the left. 5, we distributed the negative 7 to both terms, then we added 21 to both sides and divided by negative 7, and again we had to flip our sign, so x is greater than or equal to negative 7, so closed circle, shade to the right. 6, you distributed the negative 1/8, and then we added 7 to both sides, and then we divided by negative 1/8, and again dividing by a negative we had to flip our sign, so we have f is less than or equal to negative, that is a negative sign, negative 248 right there. And then in number 7 we combined our like terms, and we had negative 3m is less than 27 divided by negative 3, and again we had to flip our sign, so m is greater than negative 9, so you have your negative 9, open circle, shade to the right. So for the last 2 we combined like terms, simplified, and we got for number 8 d is less than or equal to negative 9, and for number 9 we have 5 is less than b. I was asked to include the word problems. So in number 10, you are renting a moving truck for a day. There's a daily fee of $20 and a charge of 75 cents per mile. Your budget allows a maximum total cost of $65. Write and solve an inequality that represents the number of miles you can drive the truck. So we are going to write our let statement, and we're going to have let x equal. So let x equal, that's very sloppy. Maximum number of miles. Okay, so x is their maximum number of miles. So if there's a daily fee of $20 and the charge is 75 cents per mile, you have a maximum cost of $65. That means I can take 75 cents times however many miles plus the flat rate of $20. And it can't be any more than $65. So I always put my total number over here. And I say, okay, so if it can't be any more than it, then it has to be less than. The second question I ask myself is, can it be 65 though? And that tells me, yes, I have to put the less than or equal to symbol. So you're going to solve this the same way we did the other problems, and you're going to get x is less than or equal to 60. So your final answer then is going to be the maximum number of miles is 60. I'm looking for these inequality words in your let statement and also in your sentence. So in this next one, Dr. Austin wants to save his money to buy season tickets to the Flyers. Currently has saved $2,125 and plans to set aside an additional $75 a week. Right, solving an inequality represents the number of weeks it will take for him to raise at least $4,000. So let x equal minimum number of weeks. or least number of weeks. So if he has the 2,125, that's your constant, he's already got it, and it's $75 per week, plus what he already has, and then I set my total number on the right-hand side, so the 4,000. Now I say to myself, can it be more than 4,000? Or is it only less than 4,000? So it's at least. So the word at least means that, yes, it can be 4,000 or more. So 4,000 is the lowest number, so this value can be greater than or equal to 4,000. So again, I'm going to solve it the same way we did all the other problems, and you're going to get x is greater than or equal to 25. So the minimum number of weeks is 25. Twice the difference of 4 times the number and 9 is at most 14. Find the number. So let x equal greatest number or maximum number. So twice the difference of 4 times the number and 9. So I need to have 4 times the number and 9. So the difference of those two. But I want twice that difference. So I have to put that in the parentheses to say, all right, I need twice the difference of these two values. So it has to be in parentheses. It's going to be the distributed property. And then it says is at most 14. So there's 14. That's my number. At most 14. I ask myself, can it be 14? Yes. But can it be more than that? No. So it's less than or equal to 14. You solve the problem. You'll get x is less than or equal to 4. So at most, the number is 4. I'm always looking for these inequality words. Okay, minimum, minimum, maximum, maximum, at most, at least, when you write your let statement and when you write your sentence.